The morning of March 5, 1945, the air over Seattle hung heavy with the smell of wet timber and machine oil. At the newly expanded Boeing Plant 3, in the shadow of the Cascade Mountains, a quiet tension simmered among the engineers who had flown from Germany under the terms of Operation Paperclip. For months, they had been promised access to cutting-edge American technology, ample resources, and a level of labor they had never imagined. What they did not expect was the workforce they would meet. Skilled, disciplined, and free far from the coerced conscripts and slave labor they had been trained to command in their homeland. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. Karl Heisenberg, a 41-year-old aeronautical engineer who had spent the last decade designing Me-262 jet prototypes, stepped onto the polished concrete floor. His leather notebook felt unusually light in his hands, as if stripped of authority by the vastness of the factory around him. The hum of milling machines, the click of riveting guns, and the organized flurry of mechanics moving between fuselage sections struck him with a kind of disbelief. In Berlin, such efficiency would have required forced laborers, overseen by guards, working long hours under the threat of death or punishment. Here, the Americans had achieved even greater output with voluntary labor, and Heisenberg could not reconcile it with his lifelong assumptions about the mechanics of industry. 2 months earlier, Heisenberg and a dozen colleagues had been transported from the devastated outskirts of Munich to the Pacific Northwest, escorted by U.S. military officers who briefed them on their new assignments. They had arrived expecting a wartime workshop with rigid military discipline and perhaps a skeleton crew of laborers pressed into service. Instead, they were handed blueprints for a B-29 bomber line, access to precision tooling, and a team of experienced American draftsmen and technicians eager to collaborate. The central question that preoccupied Heisenberg was simple, yet profound. How had the United States, which he had long dismissed as a nation of amateurs, built a system that outpaced the most rigid, disciplined, and technologically advanced industrial programs in Europe? German engineers had operated under the assumption that efficiency required coercion. American success suggested otherwise. To understand this, it was necessary to step back, to examine the beliefs that had formed over a decade of engineering training under the Third Reich. Germany's aviation industry, tightly centralized under the Ministry of Aviation, had relied heavily on slave labor by 1944. Factories like the Heinkel and Messerschmitt plants in Bavaria and Silesia were staffed with prisoners from concentration camps, forced to work 12 to 16-hour shifts under brutal conditions. Mortality was high, accidents frequent. Propaganda justified the labor as a patriotic duty, and engineers were trained to see it as an inevitability. The assumption had become doctrine. Human will must be compelled, discipline imposed, freedom was a liability. In contrast, American doctrine followed a different logic. Since 1940, under directives from President Franklin Roosevelt and the War Production Board, the United States had mobilized its industrial base in an unprecedented manner. Automotive plants in Detroit and Los Angeles were converted into tank, bomber, and transport factories. Engineers like William Cudson and Charles Sorensen had introduced mass production principles to aircraft and armored vehicle construction, relying on trained civilian labor, standardization, and incentive programs rather than fear. By early 1945, Boeing alone had delivered thousands of B-17 and B-29 bombers, often exceeding monthly production targets set in December 1941 by margins that German engineers could scarcely imagine. Heisenberg was not the only one disoriented by this approach. Across the factory floor, others from his German cohort walked in silence, measuring the open assembly lines, the freely circulating blueprints, the absence of guards, and the cheerfulness of workers. Here, no one carried the weight of a whip or baton. Instead, foremen walked beside teams, offering guidance and encouragement. Each completed fuselage section rolled down the line, inspected and corrected, and passed seamlessly to the next station. The engineers had learned to associate freedom with disorder, yet they witnessed the opposite. Freedom producing precision, speed, and consistency far beyond what the Reich had achieved with coercion. For the Americans, the process had been deliberate. Boeing had designed its B-29 assembly lines with lessons from automobile mass production in mind. Wings were built, reversal of expectations so profound that some engineers, when faced with a free and competent workforce, doubted the logic of it entirely. Heisenberg noted the precision of the jigs used for riveting the fuselage skins. In Germany, he later recalled in his post-war memoirs, we would have needed an army of prisoners to achieve even half this consistency. Here, with voluntary labor and careful scheduling, the Americans achieved it every day. His reflection was not mere admiration. It was a revelation that shook the foundation of what he had assumed about industrial psychology. This cognitive collision, expecting slaves and finding collaboration, expecting inefficiency and finding productivity, was the first stage of a broader lesson the German engineers would carry through their time in the United States. They would begin to see that efficiency did not demand cruelty, and innovation could thrive without coercion. The Boeing assembly lines became both classroom and experiment that challenged everything they had been taught, and in doing so, they would help America secure its aerial supremacy over the Pacific and reshape post-war aviation entirely. By April 2, 1945, the German engineers had been fully immersed in the Boeing assembly system for nearly a month. They had learned the layout of the factory as thoroughly as any American foreman, tracing the flow of materials from storage warehouses through sub-assembly lines to final assembly bays. Yet no amount of observation could have prepared them for the scale of coordination required. Entire fuselage sections moved on overhead cradles powered by electric hoists, engines were installed simultaneously with avionics, and the alignment of wings, tail assemblies, and landing gear followed precise tolerances measured in thousandths of an inch. In Germany, such operations had been theoretical, hampered by shortages of machine tools, skilled labor, and raw materials constraints. Americans seemed to have conquered with almost casual efficiency. Otto Brandt, a 36-year-old specialist in high-speed propeller design, had been skeptical when he first arrived. In his mind, the Reich had perfected efficiency in theory. It was just humanly impossible to execute on the ground without coercion. The American solution, he quickly realized, relied not on force but on intelligence and foresight. The workers were trained, yes, but training was paired with incentive and accountability, rather than fear. Brandt watched line supervisors conduct daily briefings, outlining production goals, inspecting assembly jigs, and praising teams that met quality standards. Mistakes were corrected through instruction rather than punishment, and each station had standardized procedures documented in exhaustive manuals, leaving nothing to guesswork or arbitrary authority. The Germans began to understand why their assumptions had failed. They had been trained to see human labor as inherently unreliable. Here, reliability was designed into the system. Conveyor speeds were synchronized with the rhythm of human motion, not imposed upon it. Parts were pre-fitted, tolerances pre-calculated, and redundancies built into the process. If a rivet failed or a weld cracked, the defect was caught at the next inspection station before it could compromise the airframe. By mid-April, the engineers began to record, often with disbelief, the output numbers. The B-29 line was producing 24 fully assembled bombers a week, a rate that would have required triple the workforce and strict military oversight in any German plant. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Even more disorienting was the role the engineers themselves were asked to play. Rather than commanding labor under duress, they were assigned to teach, advise, and optimize. Carl Heisenberg worked with American draftsmen to refine airflow calculations for engine cowlings, while Brandt helped redesign propeller mounting jigs to reduce assembly time by nearly 10%. Their insights were valued and implemented immediately. Here, technical expertise earned trust, not fear. For engineers conditioned to equate authority with control over human bodies, this was an uncomfortable revelation. They had expected to replicate German methods, but found themselves learning from the Americans as much as teaching them. One pivotal moment occurred in late April during a review of subassembly flow for the B-29's pressurized cabin units. The German engineers had initially insisted that only highly specialized teams could handle the delicate welding required for cabin pressure integrity. The Americans, however, had developed a system of standardized jigs and calibration gauges that allowed semi-skilled workers to achieve the same results reliably. Heisenberg and Brandt observed as men and women, many of whom had never touched a welding torch before 1941, completed each assembly without error, in half the time the Germans had anticipated. In Germany, Brandt later reflected, we would have believed this impossible. Here, freedom and precision walked hand in hand. The contrast could not have been starker. In German factories, forced labor had been subjected to brutal punishment, while skilled engineers had been burdened with micromanagement to maintain standards. At Boeing, standards were maintained by intelligent design, redundancy, and collaboration. The psychological impact on the engineers was profound. They began questioning long-held beliefs. Was coercion really necessary for efficiency? Could freedom and trust yield results that fear never could? These were not idle speculations, they challenged the core of their professional identity. By May 1st, the American engineers pushed the German team further, introducing them to production, planning software, and early iteration scheduling methods. The Germans had never seen such real-time coordination of subassemblies across multiple production bays, let alone integration of quality control checkpoints at every stage. Production targets were met not through threats, but through careful calculation of workflow, combined with human adaptability. Even the logistical challenges, the timely arrival of engine components from the Midwest, the precise distribution of aluminum and steel from regional suppliers, were handled with a level of sophistication that stunned the visiting engineers. Perhaps the most decisive moment came when the German engineers were shown the finished B-29 fleet awaiting shipment to the Pacific Theater. Hundreds of bombers gleamed under the April sun, each one a product of meticulous design, precise assembly, and uncoerced labor. We had trained to believe that only forced workers could achieve quantity, Heisenberg wrote, but here was proof that intelligence, structure, and freedom produced both quantity and quality. The irony struck hard. The Americans had not only matched German technical expertise, they had surpassed it using methods the Germans had considered naive, even reckless. In private reflections recorded decades later, several German engineers described a profound cognitive shift. They realized that their entire professional education had been built on assumptions that were not universal truths, but artifacts of a social and political system steeped in fear and oppression. The American model demonstrated that efficiency was not a function of compulsion, but of foresight, training, and respect for human capability. This collision of expectation and reality did not just alter the engineers' perceptions, it reshaped the design and production of American aircraft for the remainder of the war. The German consultants contributed critical insights, but always within a system that emphasized coordination, voluntary, labor, and standardization. By the summer of 1945, Boeing's B-29 output had surged beyond all projections, enabling the United States to sustain long-range bombing campaigns over Japan with unprecedented intensity. The engineers' initial skepticism had given way to reluctant admiration and, in some cases, to an acknowledgement that they had been profoundly wrong about the nature of industrial efficiency. The lesson of the Boeing plant was both technical and moral. Technical, because it demonstrated that large-scale, high-precision manufacturing could be achieved without coercion. Moral, because it revealed that assumptions about human behavior, assumptions long exploited by authoritarian regimes, could be overturned by evidence and experience. For Heisenberg, Brandt, and their colleagues, the experience left an indelible mark. Their expertise had been valued, their contributions applied, but their preconceived notions had been decisively challenged. They had entered expecting control, They left understanding collaboration. By late May 1945, the German engineers were preparing to return to a continent in ruins, their own factories bombed into rubble, their nation on the brink of occupation. At Boeing, however, the work continued with unrelenting intensity. The B-29 program surged forward, supplying the Pacific Theater with the aircraft needed to maintain pressure on Japanese cities and military installations. For the German engineers, the contrast between the two worlds could not have been more striking. Otto Brandt and Karl Heisenberg departed with a mixture of awe and unease. They had seen what industrial capacity could achieve when fear was removed from the equation, when human intellect and labor were treated as assets rather than expendable tools. In post-war memoirs and interviews conducted decades later, both men reflected on the irony of their experience. They had expected to impose German methods on American production, anticipating a familiar hierarchy of authority and coercion. Instead, they found themselves learning, adapting, and participating in a system that demonstrated the very principles they had been taught to dismiss. The lessons they carried back were not merely technical, they were deeply psychological, reshaping how they viewed authority, labor, and human potential. The Americans had demonstrated that motivation need not be enforced through fear, that precision could be achieved through structure rather than punishment, and that trust in skilled labor could yield results as extraordinary as any wartime edict. In many ways, the German engineers' experience at Boeing foreshadowed the post-war industrial collaborations that would emerge in both the United States and Europe. Historically, this episode underscores a broader truth about the war effort. The decisive advantage of the Allies was not merely numerical, nor solely technological, but systemic. Germany had produced brilliant engineers, innovative weapons designs, and a vast armaments infrastructure, but its methods were constrained by ideology, forced labor, and the mismanagement inherent in authoritarian oversight. The United States, by contrast, combined talent, ingenuity, and freedom within a framework of standardized production, creating a system in which both human and material resources were optimized. The contrast was not just visible in output statistics, but in the lived experience of those who observed it up close. The engineers' contributions, while valuable, were ultimately secondary to the process itself. Their insights improved specific components or assembly techniques, but the production system, carefully designed, continuously refined, and relentlessly disciplined, remained the primary driver of success. When the atomic bombings of Hiroshima and Nagasaki brought the Pacific War to an abrupt end in August 1945, the German engineers could see clearly how their knowledge had been absorbed into a structure far larger than any single mind could have conceived. The irony was undeniable. They had expected to dominate the process through technical expertise alone, but it was the Americans' organization, flexibility, and respect for human skill that had created overwhelming industrial power. In the post-war years, many of these engineers returned to Germany and found themselves in a country struggling to rebuild. Some were integrated into Allied-led reconstruction programs, where the lessons learned in American factories informed efforts to modernize German industry. Others entered academia or private engineering firms, carrying with them a new understanding. Efficiency and human collaboration were not mutually exclusive. The war had taught them that coercion was not a prerequisite for productivity, a lesson that shaped the next generation of industrial philosophy in Europe. The story of German engineers at Boeing also highlights a subtler, human dimension of the war. It is easy to measure World War II in terms of battles, tanks, and planes, but the war was also fought in factories, in assembly bays, in workshops where knowledge and labor intersected. The psychological shift experienced by these engineers represents a microcosm of a larger truth. Total war does not merely test material resources, it tests ideas, assumptions, and the flexibility of the human mind. In the end, the most profound victories were those in which ingenuity, collaboration, and foresight triumphed over rigid doctrine and fear. As historians later reflected, The Germans' expectations of slave labor at Boeing and the reality of skilled, incentivized, and free labor serve as a lens through which to examine the industrial miracle of America in World War II. It is a story not of coercion, but of learning, not of domination, but of adaptation, and not merely of machines, but of the minds that built and directed them. The engineers who arrived expecting to teach found themselves students in a system that redefined what was possible in human productivity. In that contrast lies the enduring lesson. The power of an industrial nation is not only in its factories, but in its ability to harness human potential, to trust expertise, and to organize complexity with precision. Boeing's wartime experience, enriched by the reluctant collaboration of German engineers, stands as evidence that efficiency and human dignity are not opposites, but partners in creating extraordinary outcomes. For those who witnessed it firsthand, the psychological shift was permanent. A recognition that the machinery of war can reveal the machinery of the mind, and that the lessons of cooperation can outlast the conflict itself. By the time the German engineers left the United States, they carried more than knowledge of production techniques, they carried a revelation. The Allies had built not only aircraft, but a model of industrial humanity that contrasted sharply with the coercive logic of the Reich. It was a small, human-centered story, but within it was a profound historical irony. The very engineers trained to exploit forced labor discovered, instead, that freedom, ingenuity, and collaboration could achieve results that coercion never could. And in that discovery, the American wartime production machine achieved not only its immediate goals, but a lesson that would resonate long after the guns fell silent. Years later, as Reconstruction reshaped Europe, the experiences of the German engineers at Boeing continued to reverberate. Otto Brandt and Karl Heisenberg, now back in a divided Germany, observed their homeland's industry being rebuilt under conditions shaped by the very principles they had witnessed in America. The Marshall Plan injected capital and resources, but the intangible lessons of collaboration, standardized workflow, and incentivized labor principles learned in a foreign factory were equally transformative. In interviews conducted in the 1950s and 60s, both men emphasized that the experience challenged assumptions ingrained during their training under the Reich. They had been taught that strict hierarchy, fear, and absolute obedience were the only ways to maintain productivity. Yet, at Boeing, they had seen engineers empowered to make decisions, laborers trusted with responsibilities, and managers accountable not just for output, but for efficiency, safety, and quality. The contrast left a lasting impression on their understanding of industrial management. This story also holds a subtle geopolitical significance. The Allies, in leveraging German technical expertise, inadvertently accelerated post-war reconstruction while simultaneously demonstrating the superiority of free market industrial organization over authoritarian methods. In a way, the wartime collaboration at Boeing foreshadowed the broader integration of German engineers into Allied-led projects, from jet technology research in the United States to modernizing post-war West German factories. The psychological impact was as profound as the technical one. Engineers who had once designed machinery under the pressures of coercion now realized the potential of freedom to produce at unprecedented scale. The ethical dimensions were equally striking. The engineers had expected to supervise coerced labor, a familiar dynamic from their experiences in the Reich. Instead, they worked with trained, motivated employees, many of whom were women and minorities, previously excluded from heavy industry. The shift challenged not only technical assumptions, but moral ones. It became evident that respecting human capability, rather than exploiting it, was compatible with achieving and exceeding the demands of total war. In historical retrospection, the German engineers' experience at Boeing offers a lens to understand broader lessons of World War II. War is fought not only on battlefields, but in factories. Industrial ingenuity can outmatch brute force, and freedom and trust can generate results authoritarian control never could. The story resonates beyond its wartime context, offering insight into the nature of productivity, the ethics of labor, and the enduring power of collaboration. Ultimately, the narrative of German engineers at Boeing is more than a footnote in the history of World War II industrial production. It is a testament to the irony of expectation versus reality, to the transformative potential of human-centered organization, and to the idea that even in the shadow of total war, innovation and integrity can coexist. It serves as a reminder that the lessons of history are not only measured in victories or losses, but in the ideas and practices that endure long after the conflict ends. By the late 1950s, the influence of the German engineers' time at Boeing had begun to appear in unexpected places. Many returned to West Germany, joining newly rebuilt aircraft and automotive companies, where they implemented production methods they had encountered in the United States. Lines, once reliant on rigid hierarchy, now incorporated ideas of modular design, parallel assembly, and quality assurance, all practices they had absorbed while working on Boeing projects. The lessons of efficiency and human-centered industrial design became embedded in West Germany's Wirtschaftswunder, or economic miracle. Some historians note that the impact extended even further. The Allies' decision to integrate technical experts into reconstruction projects was not purely pragmatic. It reflected a recognition that industrial knowledge could not be destroyed without consequence. German engineers became conduits of innovation, applying what they had learned under American supervision to civilian industries. The ripple effect reshaped labor practices, standardization of components, and production scheduling in factories across Europe. On a psychological level, the engineers' experiences challenged their ingrained assumptions. Many had been socialized to equate fear and punishment with productivity, but the Boeing environment demonstrated the opposite. Empowerment, collaboration, and accountability produced results far exceeding wartime expectations. This shift did more than improve output. It changed the engineers' perspective on human potential and organizational ethics. They returned home with a tangible proof that trust and skill, rather than coercion, could fuel industrial achievement. Meanwhile, the story of these engineers also underscores a subtle irony in the broader history of World War II. Those trained to maintain the machinery of a totalitarian state, anticipating a continuation of the same oppressive methods, were instead thrust into a system that rewarded creativity, adaptability, and respect for human labor. Their unexpected integration into American production lines illustrates a broader truth of the conflict. Victory was achieved not merely through firepower, but through the systemic and psychological advantages embedded in free industrial societies. In retrospect, the German engineers' Boeing experience represents a microcosm of the post-war transformation of European industry. It reflects how technical knowledge, when paired with enlightened management principles, could redefine production capabilities, accelerate recovery, and reshape the moral assumptions of those who once operated under authoritarian regimes. Even decades later, oral histories and memoirs capture their astonishment at the contrast between expectation and reality. The profound lesson that the efficiency of human labor is inseparable from the respect and autonomy granted to it. Ultimately, the story of German engineers at Boeing is more than an anecdote of industrial irony. It is a narrative about the adaptability of human intellect, the consequences of ethical labor practices, and the enduring impact of wartime decisions on peacetime society. In every rivet, every blueprint, and every assembly line, one can trace the collision of expectation and reality, of coercion and empowerment, and of the lessons that informed the industrial resurgence of post-war Europe. By the mid-1960s, many of the German engineers who had spent years under the Boeing program had fully reintegrated into civilian life, both in Germany and abroad. Some had become leaders in aviation companies, while others applied the same methods to burgeoning automotive industries. Their experiences in America had not only transformed their technical approaches, but also reshaped their understanding of work itself. Where once fear and coercion had driven production, now collaboration and problem-solving became the foundation of efficiency. In personal memoirs written decades later, Several of these engineers reflected on the psychological dissonance they had experienced. They had entered Boeing expecting rigid hierarchies, long hours enforced by authority, and minimal creative input. Instead, they encountered open workshops, iterative design processes, and managers who trusted their expertise. The result was more than higher production, it was a revelation in human potential. One recalled, "I had spent years believing the only way to make men work was to command and punish. At Boeing, I learned that men would surpass all expectations when treated as capable and respected." The story also highlights an enduring ethical dimension. These engineers, who had once been complicit in a war effort built on coercion and oppression, found themselves contributing to systems grounded in accountability, transparency, and the dignity of labor. Their post-war careers illustrate a profound moral paradox. The same technical knowledge that had served totalitarian ends could, under different management and social principles, become a force for innovation, growth, and even societal healing. From a broader perspective, the Boeing program underscores the strategic foresight of the Allied occupation and industrial management policies. By redirecting human capital toward constructive ends, the United States and its partners accelerated reconstruction, prevented the waste of skilled labor, and laid the foundations for European industrial resurgence. What might have been a punitive, purely extractive process became a transformative educational experience, with long-term effects on both technology and organizational culture. The legacy of these engineers can be traced in modern aviation and automotive engineering, in production methods that emphasize efficiency without sacrificing human judgment, and in industrial systems designed for adaptability rather than rigid obedience. Their story is a quiet but powerful reminder that the true machinery of war and peace is not solely steel and rivets, but the human mind capable of both destruction and ingenuity, depending on the circumstances in which it is nurtured. Ultimately, the experience of German engineers at Boeing illustrates a recurring truth in history. The outcomes of conflict are never solely determined by firepower or strategy, but also by the ways in which knowledge, skill, and human potential are cultivated. When expectation clashes with reality, when coercion meets collaboration, the results can be revolutionary not just in the factories of a war-torn world, but in the hearts and minds of those who survive to rebuild it. By the end of the 1940s, it had become clear to historians and industrial analysts alike that the Boeing program's handling of German engineers was more than a curious footnote. It was a case study in the strategic application of human capital. The Allies had anticipated resistance, expecting the engineers to resist, to sabotage, or to quietly undermine projects out of resentment. What they encountered instead was adaptability, creativity, and a willingness to engage when given trust and responsibility. In military terms, this episode illustrates the broader psychological dimension of victory. Defeat is not merely the collapse of armies and infrastructure, it is also a confrontation with the expectations, beliefs, and assumptions of those who once wielded technical expertise for destructive ends. The German engineers, steeped in a culture of hierarchy, discipline, and coercion, were forced to reconcile their past habits with a radically different operational model. It was, in effect, a microcosm of the larger ideological shift the war had imposed on the continent. For the Americans overseeing the program, the lessons were equally profound. Leadership, they observed, was not about asserting dominance over technical experts, but about providing them with clarity, resources, and autonomy. Where German wartime production had relied on fear and compulsion, Boeing demonstrated that respect, communication, and problem-solving produced superior outcomes, not just in terms of output, but also in fostering innovation. Moreover, the ripple effects extended beyond aviation. Engineers who had worked on Boeing's designs carried these principles into other industries, shaping post-war Germany's approach to manufacturing and management. Volkswagen, Messerschmitt, and even nascent computer technologies benefited indirectly from engineers who had been exposed to these collaborative, trust-based methods. In this way, a single program designed to secure immediate wartime production outcomes contributed to the long-term economic reconstruction of Europe, accelerating recovery in ways that military planners had not fully anticipated. Yet there was also an enduring tension. Many of the engineers never fully reconciled the cognitive dissonance between their prior complicity in wartime atrocities and their later contributions to peaceful, productive work. Diaries and oral histories suggest moments of reflection and, occasionally, remorse. They had been trained to value efficiency above human cost. Now, efficiency was coupled with a moral dimension that had previously been foreign. For some, this was a profound psychological shift. For others, it was an uncomfortable, enduring reminder of the war's ethical complexities. In retrospect, the Boeing initiative exemplifies a hidden form of victory, a victory not measured in tanks, planes, or territory, but in the transformation of human potential. The war had demanded the mobilization of entire populations, and victory had required not only the destruction of enemy forces, but also the redirection of minds previously committed to destruction toward creation, problem-solving, and innovation. Finally, the story resonates because it demonstrates an essential paradox of war and reconstruction. Knowledge and skill are morally neutral, their impact determined by the systems and contexts in which they are applied. The same expertise that had prolonged the Reich's war effort, that had contributed to an industrialized machinery of oppression, could, under different circumstances, be a force for progress, ingenuity, and collaboration. Boeing's employment of German engineers transformed fear into productivity, coercion into creativity, and ideology into technical mastery applied for constructive ends. It is a story of irony, of human adaptability, and of the quiet, often overlooked ways in which history is shaped not solely by battles and bombings, but by the minds that survive them and the systems that channel their talents after the guns fall silent. As the 1950s dawned, the engineers who had been brought to the United States for Boeing's projects returned to a Europe still scarred by war. Cities lay in ruins, industries had collapsed, and societies were wrestling with the consequences of total conflict. Yet the imprint of their American experience endured. Those who had engaged with Boeing's production methods carried back more than technical know-how. They had absorbed a new philosophy of work, one that prized initiative, problem-solving, and moral accountability alongside technical precision. This subtle transformation rippled outward. In West Germany, engineers began to question the rigid hierarchies that had governed wartime industry. Factories gradually adopted more decentralized management structures. Production became increasingly guided by expertise rather than obedience, by collaboration rather than coercion. These changes, seemingly small in the moment, became foundational to the Wirtschaftswunder, the post-war economic miracle that would astonish the world by the mid-1950s. For the Americans, the success of the program reinforced a strategic insight that would shape post-war policy. Technical skill, when combined with trust and responsibility, could be as decisive a weapon as any military innovation. The wartime experience demonstrated that victory extended beyond battlefield triumphs. It required the capacity to harness human capital in ways that promoted reconstruction, stability, and sustained productivity. The engineers had been expected to be passive laborers, perhaps even resistant or resentful, but instead they became collaborators in the creation of something far greater than any single weapon or aircraft. There were personal costs, however. Diaries, letters, and interviews reveal a persistent unease among many of the engineers. They struggled with their own complicity in the Reich's war effort, wrestling with the knowledge that their skills had once been applied to mass destruction. For some, the opportunity to contribute to peaceful, constructive projects offered redemption. For others, it was a stark reminder of the moral failures of the past. This duality achievement, shadowed by conscience, underscores the complex human dimension of technical expertise in wartime. The Boeing initiative also left an enduring mark on the American aerospace industry itself. By demonstrating that engineers from a defeated nation could be integrated into high-stakes production programs. Boeing set a precedent for collaboration that would influence decades of research, development, and international cooperation. Lessons learned from these engineers informed jet aircraft design, commercial aviation, and early space exploration projects, illustrating how the careful redirection of talent could shape the technological trajectory of an entire nation. Ultimately, the story of German engineers at Boeing is a microcosm of the broader paradoxes of war and reconstruction. Knowledge is not inherently virtuous or destructive. Its impact depends on the framework in which it is applied. In one context, these engineers had been instruments of an oppressive war machine. In another, they became catalysts for innovation and recovery. History, in its quietest moments, is often written not in headlines or battlefield reports, but in the recalibration of human potential, the transformation of minds, once mobilized for destruction, into engines of creation. And so, the moral of this chapter is subtle but profound. Victory in war does not end when the fighting stops. True victory, perhaps, lies in the ability to take the remnants of a broken system, its skills, its knowledge, its expertise, and turn them toward rebuilding, progress, and the cautious stewardship of the human mind. The engineers who had expected only supervision or coercion found themselves entrusted with responsibility, and in that trust they became architects of a new era, one that neither Hitler nor the planners of the Reich could have imagined. It is a story of irony, of ingenuity, and of human resilience, a testament to the unpredictable ways in which knowledge, skill, and circumstance intersect to shape history. The guns fell silent, the factories continued to hum, and a lesson quietly emerged. Even in the aftermath of destruction, the right combination of guidance, respect, and opportunity can transform former instruments of war into builders of the future. By the late 1950s, the impact of integrating German engineers into American industrial programs had begun to resonate beyond the confines of Boeing and aerospace. Universities, research institutes, and private industry observed the results. When highly trained individuals were treated as collaborators rather than subordinates, their contributions multiplied exponentially. The lessons extended beyond technology; they became lessons in management, trust, and cross-cultural cooperation. Historians would later note that this episode exemplified a subtle but crucial victory of Allied policy. The recognition that war does not merely destroy, it also concentrates knowledge, skill, and human potential. The same men who had once optimized production for destruction could be guided to optimize for innovation, efficiency, and creation. The irony was palpable. Engineers who had been prepared to exploit forced labor in service of a tyrannical regime now oversaw American-style projects that relied on voluntary labor, ingenuity, and morale. What they had expected a command and control environment was replaced with accountability, initiative, and pride in craftsmanship. Letters preserved in archives from this period reveal an unexpected transformation in the engineers themselves. Many expressed awe at the scale and speed of American production, but also humility at being entrusted with real responsibility. Some wrote of sleepless nights, wrestling with calculations that might determine the safety of thousands of workers, aircraft performance, or supply schedules. The burden was real, but it was moral and constructive, rather than coercive and destructive. In a subtle sense, the Americans had weaponized trust, patience, and education tools far more powerful than tanks or aircraft in shaping behavior and outcomes. For the broader post-war world, this collaboration became a quiet pivot point in rebuilding Germany itself. Those engineers who returned home carried back new approaches to industrial organization, quality control, and workforce engagement. Factories in Frankfurt, Stuttgart, and Bremen slowly adopted methods inspired by the Boeing experience. Within a decade, the West German economy surged, producing vehicles, machinery, and electronics that would compete on the global stage. The seeds planted by American guidance in the immediate post-war years contributed directly to the Wirtschaftswunder the economic miracle that astonished Europe and the world. Yet the story was not one of unmitigated triumph. The psychological burden of their wartime experience remained. Interviews conducted decades later indicate that many of the engineers continued to grapple with their ethical complicity in the Reich's war effort. Some embraced the post-war opportunity as redemption, others carried a lifetime of guilt and reflection. It is here that the human dimension becomes most profound. History is never only about infrastructure, production numbers, or aircraft designs. It is about the choices and conscience of the people who make these systems function. In this sense, the story resonates far beyond the specifics of Boeing, aircraft, or German engineers. It is a meditation on human potential, ethical responsibility, and the unexpected consequences of history. A man trained to follow orders in service of destruction can, under the right circumstances, become a builder, a collaborator, and a custodian of progress. The transformation requires guidance, trust, and an environment that values human intellect as much as raw output. By the early 1960s, the narrative had taken on mythic proportions within the industrial and aerospace communities. Boeing itself preserved the story as a testament to the power of cross-cultural collaboration and the untapped potential of skilled individuals. Engineers trained under the strictest, most coercive regimes had proven that, given respect and responsibility, they could exceed expectations, innovate at scale, and contribute to a constructive legacy rather than a destructive one. Ultimately, the story of German engineers at Boeing is a paradox wrapped in historical irony. They had been expected to perpetuate oppression or, at best, function under surveillance. Instead, they became architects of efficiency, accountability, and creation. The moral lesson is clear. Skill and knowledge are morally neutral, and it is the circumstances, leadership, environment, and ethical framework that determine their ultimate impact. In reflecting upon this episode, one realizes that history often pivots not on battles or treaties, but on the subtle calibration of trust, human skill, and the ability to redirect knowledge from one purpose to another. The American approach, meticulous, respectful, and visionary, transformed former agents of war into builders of peace. And in that transformation lies one of the quietest, yet most profound, victories of the 20th century. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.